Okay, so we continue to the lesson 7 based on to the main type of the organic reaction, and also we try to identify the type of organic reaction. So in organic reaction, we have the several types, which is additions. It involves electrophilic and nucleophilic process. Substitution, you have three processes: electrophilic, nucleophilic, free radical. Elimination reaction and rearrangement reaction. In addition reaction, okay, we must consider two types of them: electrophilic addition and another part is nucleophilic addition. If addition, we are focused to the process of added. So, according to the site of chemical reaction, sites of the organic compound, you must identify the presence of multiple bond. So, either carbon-carbon double bond of alkene, or carbonyl compound, which is C double bond O, or C double bond C. Remember, if the reaction is a addition, you must be find out inorganic compound must be have either carbon-carbon double bond or carbon double bond O. So, if they are electrophilic addition reaction, so the first thing you must be refer to the organic compound. Who is our functional group? It must be carbon-carbon double bond. This carbon-carbon double bond can be formed partially negative side. So, this we can label as a nucleophile site. So, if we have the carbon-carbon double bond, the type of reaction according to our reagent, so this we are classified as our reagent. So, this reagent will added to the carbon-carbon double bond. So, we can classify this will become electrophile species. So, remember, if addition, so why we can call electrophilic? Because we add positively charged species. Okay, so when we are traced according to the compound consists of the carbon-carbon double bond. So this carbon double bond have 1, 2, 3, 4 electron. So this will become partially negative side. So, bila partially negative side, this is nucleophile side. So, the species must be added. For example, we use a bromine atom. Both bromine atom in molecule are same electron negative. So, this electron means this bromine atom, one of the bromine atom will become partially positive and this will become partially negative. So, when the species added to the carbon double bond, we identify partially positively side is added to the carbon-carbon double. Next, if nucleophilic addition, your organic compound must be have a C double bond O. So, the chemical reaction takes place at this. So, this become partially positively side because carbon attached to the more electron negative element. So, in HCN, it consists H plus and Cn minus ion. So, if the site is positively charged, which is electrophilic site, the species added must be negatively charged. So, means yang added dekat dia adalah negative. So, this is why the process involve nucleophilic addition reaction. Okay, next. If the process involved is substitution, we have a three part, either free radical, electrophilic, or nucleophilic substitution reaction. So this spelling is incorrect. So it must be nucleophilic substitution reaction. So remember, your organic compound must be the saturated compound, either alkane, alkyl halide, alcohol, or aromatic compound. So we go first, which is we can call free radical substitution reaction. If the free radical substitution reaction, the mean of the process involved, we must identify the presence of the sunlight UV. So therefore, this we can call free radical substitution according to the presence of UV. If electrophilic substitution reaction, your organic compound must have higher electron density site, which is carbon-carbon double bond, partially negative side. This is also partially negative side. This is also partially negatively side. But according to the aromatic compound, one of the carbon atom here have one hydrogen atom. So the process is substitute. So we eliminate H plus ion and we substitute Br plus ion to it. So this is we can call electrophilic substitution reaction. If a nucleophilic substitution reaction, you must have the electrophile, which is the saturated compound. For example, we have a partially positive and partially negative. So chemical reaction take place at the functional group. Functional group kita adalah bromine. So bromine keluar, dia akan jadi Br minus. So yang masuk tersebut adalah OH minus. So this is we can call nucleophilic substitution reaction. So if the process of elimination means from all the single bond here will become carbon-carbon double bond. So for the last, if the process involved is the rearrangement, so the number of atoms are same but they are in different carbon skeleton, which is we rearrange them again. So from the carbon-carbon double bond, we rearrange to become C double bond O. So this is the rearrangement process. So we go to the example. If in example 1, how you find out the type of the chemical reaction? First, this is organic compound, all of them single bond. So this is saturated. But we have the one of the functional group OH. So if this is OH, OH will eliminate, will become OH minus. And therefore, what happened, the final product, the presence of the carbon-carbon double bond. So means the first thing OH remove, second part hydrogen H plus remove. So finalize, we can eliminate water. So means the type of reaction is elimination reaction because we eliminate the compounds of water and it can produce carbon-carbon double bond. For the B question, our organic compound is saturated also, but we have the halogen. And the final product, halogen will replace by OH. So means when Br is removed, it will become Br minus and OH is added. So this OH is OH minus. So if both of them are negatively charged, means they are nucleophile species. So the process involves substitution. So the type of reaction is nucleophilic substitution reaction. Okay, for the equation C, the differences of the reactant and also the product, hydrogen atom and CH3 group. So mean the process involved, they are aromatic. We replace hydrogen by CH3. Hydrogen will become the electrophile species. Mean this process involved is electrophilic substitution reaction. Okay, for the D equation, the differences our organic compounds is the presence of the hydroxyl and we replace by chloride. So means from alcohol to produce haloalkane. So we eliminate OH minus nucleophile species and we replace by Cl minus nucleophile species. So the process involves nucleophilic substitution reaction. And for the last, the presence of UV, we know that this is one of the process we can call free radical substitution reaction. Okay, next for the question F, the presence of the multiple bond, but this is carbon C double bond O, and we are trace this carbon attach the more electronegative, oxygen become partially negative side, carbon will become partially positive side. So therefore, if the multiple bond, the process involved must be addition reaction. But the problem here, who must be added to the C plus? So therefore, the added must be different charge toward to the side. So Cn minus will added to the partially positive side. So Cn minus is nucleophile species. So the process involved must be nucleophilic addition reaction. Okay, and for the last, also carbon multiple bond, carbon-carbon double bond. So this will become partially negatively side. So the positively charge must be added here, which is a Br plus. So the process involve electrophilic addition reaction. So your task must be complete example number 2. Exercise number 1, exercise number 2, and also exercise number 3. So we have exercise number 3 at the end of year. For next we discuss according to the quizzes question.